Hello everyone. Hi. So welcome to Vaayusastra Aerospace's Future Scientist Meet chapter number 39. So today we have three presenters, like four presenters actually. So two from school level, two from college level, and they are going to do their research work. So for those who are seeing it the first time, let me introduce what is Vaayusastra. Vaayusastra is an IIT incubator startup spreading awareness of aeronautics and aerospace among school children and college students using holistic methods, hands-on methods. And we designed curriculum from age 5 onwards uh, till like college level. And it's all hands-on. And we have online module which is specially designed during pandemic. It's called Trigger the Spark. So in Trigger the Spark, where it's a design after researching about life of people like Elon Musk, Wright brothers, and Abdul Kalam, and much more, many more scientists. That there's a moment in their life which actually triggered the spark. So in Trigger the Spark module, we combine stories, science, and simple hands-on maths. So all these things were so it happened, and after 8 or 9 levels in future scientists like Trigger the Spark module, students were put in a group of young researchers group, Vaayusastra young researchers group, where they get to do research on their favorite topics. This was happening for 6 to 7 months, and one day accidentally we happened to go on live, and we get to reach much more audience from a worldwide audience. So we thought it is a good way to exhibit the talents of young researchers and college students. So that's how it all started. Today we are in 39th chapter, and today we have Naman, who is going to present on his series, the planets and planets of solar system and beyond. And those who are following Vaayusastra, future scientist mail, they definitely know Naman. He is almost presented every week or every alternate week. So this is like his 15th chapter or 15th part of this parts of planets of solar system and beyond. He is a grade 5 student from Ekya school, BTM. So Naman, you can start.
Okay, first of all, thank you, Jaco, for introducing me. So, without any further ado, I will just click on present and share screen. Should load. Okay, so planets of the solar system and beyond, part 15 by Naman Aerospace Now, which is me. A quick note to whoever isn't familiar with my presentation. So, this is a series where I talk about planets of the solar system and further to the exoplanets, which are successfully reached, and this will go on until I run out of planets to discuss on. Thank you and enjoy. I might do other presentations in between. Okay, so couple rules while I present. No interruptions. Questions at the end of the presentation. Interactions are clearly allowed. Raise your hand to interact. Feedback and suggestions at the end. Now, enjoy. So Kepler 69c. Okay. What kind of an exoplanet is Kepler 69c? Kepler 69c, also known as Kepler Object of Interest Designation, also known as KOI or KY 172.02, is a confirmed super-Earth extrasolar planet, likely rocky, orbiting the Sun-like star Kepler 69. Of course, the outermost of two such planets discovered by NASA's Kepler spacecraft. It is located about 2,430 light-years or 706 parsecs from Earth, and the discovery of the planet was announced in April 2013 by NASA as a part of the Kepler spacecraft data release. The exoplanet was found by using the transit method, which was most likely used in all other Kepler planets, in which the dimming effect like a planet causes as it orbits in front of its star is measured. So Kepler 69c is a super Earth, an exoplanet which has a radius and mass larger than Earth, but smaller than that of the ice giants Uranus and Neptune. It has an estimated equilibrium temperature of 325 Kelvin, which is 52 degrees Celsius, which is already hot, but likely has a far hotter surface temperature of 548 Kelvin, which is 275 degrees Celsius. It has estimated mass about 0.14 Earth mass and a radius of 1.71 Earth radius. These characteristics make it an analog to Venus, but more massive, so it is called a super Venus. So the properties are pretty much simple as Venus, but just more massive. So, a bit of continuation. 2009, NASA's Kepler spacecraft was observing stars with its photometer, an instrument it uses to detect transit events, in which a planet crosses in front of and dims its host star for a brief and roughly irregular period of time. In this last test, Kepler observed 50,000 stars in the Kepler input catalog, including Kepler 69. The preliminary light curves were sent to the Kepler science team for analysis, who chose obvious planetary companions from the bunch of follow-up observatories. Observations for the potential exoplanet candidates took place between 13th May 2009 and 17th March 2012. After observing their respective transits, which for Kepler 69 occurred roughly every 242 days, which is more than half of 1 year on Earth, technically, which is the orbital period. Kepler 69c's orbital period is what I mean. It was eventually concluded that a planetary body was responsible for the periodic 242 day transit. Discovery along with the planetary system of the star Kepler 62 announced on April 18, 2013. On 9th May 2013, the congressional hearing by two U.S. House of Representatives subcommittees discussed exoplanet discoveries. Now we found other Earths, and pretty much similar to Kepler 452b, prompted by the discovery of exoplanet 69c, along with Kepler 62e and Kepler 62f. A related special issue of the journal Science published earlier described the discovery of the exoplanets. Can Kepler 69c be colonized? Simple question. Exoplanets, along with the exoplanets Kepler 62 and F, were announced in the media as being located within the star's habitable zone, which is basically a region where liquid water could exist on the surface of the planet. It was described as being one of the most Earth-like planets, given the size and temperature yet found, and according to scientists, a prime candidate to host alien life. Due to uncertainties in the stellar parameters, the error bars and the value of the incident flux on this planet are quite large. At 1.0 minus 0.56 times the level of Earth. Using the nominal parameters, the planet is too close to the star to be habitable, though the uncertainties allow for the possibility that it may actually lie in the innermost region of the habitable zone and be a desert planet. However, even with the lowest error bar measurement, a stellar flux of 1.35 would still be high enough to boil away any. A more recent analysis has shown that the planet is likely more analogous to Venus, which is known to be one of the most hospitable places to live in the solar system, and thus highly unlikely to be habitable by two such. So technically, as I said, Kepler 69c is as hot as Venus, so we might not be able to colonize it. But Venus, of course, has its atmosphere, which we can build buildings on, surprisingly. So, a quick and short video on Kepler 69c.
your host.
NASA's Kepler mission has discovered 3 super-Earth-sized planets orbiting in the habitable zone of their stars. The habitable zone is the distance from a star where the surface temperature of an orbiting planet could be suitable for liquid water. Each of the 3 new planets is less than twice the size of Earth. About 1,200 light-years from Earth, 2 of the newly discovered planets are in a 5-planet system called Kepler 62. The host star is smaller and cooler than our Sun and has 3 planets that orbit very close, making them hot, inhospitable worlds. Farther away are 2 planets in the habitable zone. Orbiting on the inner edge of the habitable zone is Kepler 62e. It is about 60% larger than the size of Earth and orbits every 122 days. The smallest of the habitable zone planets is called Kepler 62f. It is 40% larger in size than Earth and is likely a rocky world. Kepler 62f orbits every 267 days. These 2 planets are the smallest yet discovered in the habitable zone of another star. Much farther away, about 2,700 light-years from Earth, is a 2-planet system around a star called Kepler 69. The star is the same type and very similar to our own Sun, although it is slightly smaller and cooler. The inner planet, Kepler 69b, is 2.2 times the size of Earth and orbits every 13 days. It is much hotter and closer to its star than the planet Mercury is to the Sun. The outer planet, Kepler 69c, is about 70% larger than Earth and orbits every 242 days. It is the smallest planet found in the habitable zone of a Sun-like star. Managed by NASA Ames Research Center, the Kepler mission is using a space-based telescope to search one part of the galaxy for potentially habitable planets. While scientists do not know if life could exist on the newfound habitable zone planets, their discovery signals another step closer to finding a true Sun-Earth twin.
Quiz time. So if you have any doubts on Kepler 69c, you can ask Naman. So Naman is kind of, I think, he'll become an encyclopedia of all these Kepler planets. He has on range of understanding about all this, like how this exoplanets work. Let's see. Super, Naman. Okay. So this we definitely. We can probably. So Vignesh, what do you think about all these exoplanets?
I think so. They might support life because so many people have been presented from that. There might be lives on exoplanet and humans can survive. Okay. I think so. That's my wish. I think so. That's so.
Sir, actually, Naman has presented many times this topic, so like the 15th
Yeah,
time.
yesterday, that's Jagu, I think so we need to research on it more deeper. Because until this, everyone who had presented, I have found it that the life might be there, but we need to just research. I think so.
There are many candidates, I'm telling you.
Yeah, but there are many Kepler candidates which might.
Yeah. Yeah.
Kepler only is enough actually for that, and on top of that, you have other telescopes also like the Hubble, which might.
See, there is one moment I think so. This you told about this Hubble telescope, no? That Hubble telescope, I think the James Webb telescope is little bit bigger than this Hubble telescope.
I've just seen that even Hubble telescope is there.
Yeah, let's see what details.
Say, join the quiz. Join the quiz.
Okay, Joe, joining. Jago, I have joined.
Okay. Others, I'm trying to put the link in the research group through computer. So you can just copy paste the link in research group.
There are so many candidates, we can have our own private planet itself.
Yeah. That also could happen, possibly. Just that first experimental travel should be a successful one.
Let's see, I have joined.
Then a lot of people, then things will become easier. See, 4 join. Vignesh, put this link in the WhatsApp group. No? Put it in.
Oh, Jago, but I do not have the WhatsApp in my computer. I think I need
Okay.
to send via Gmail.
Jago, I'll send. Just a sec. I'll pass.
3 connected, waiting that goes.
Jago, where are these exoplanets located?
That some 1,000 light years away.
It's in another galaxy.
Yes,
It might actually it might be nearby only. Like it's like Proxima B is in our galaxy only. It's orbiting around the Proxima
Oh.
Centauri.
Okay,
It does
I
not have to
think
be very
so.
far.
No, you confused the solar system for galaxy.
See,
Outside
yes,
of solar
I
system,
think
but
so.
it's
I
not the
have one
galaxy only.
idea. Okay, it might be little bit in Andromeda and Milky Way galaxy. Little bit.
Ada, listen to me first of all. It is in every solar system there'll be an exoplanet. That's all. So if and in one galaxy there are billions of solar systems, and in
Yeah.
one solar system only sometimes there'll be many.
Like Earth
Sometimes there'll be one.
itself, in Andromeda galaxy, there might be a planet.
Ada, it's not
It's
galaxy,
just
okay?
imagination only.
Okay,
Okay,
no,
some Greek scientist had imagined saying
okay,
that
it is just outside our solar system. Is called exoplanet. That's all.
yeah.
Yes.
Aman, you can start the quiz.
Yeah, you can start.
One more is joining.
Okay.
Because Jago, like if I start, everyone will start joining. Like it will become 5, 6, 7, 8, 9, 10. Is Kepler 69 still habitable?
You can read the questions. What is Kepler object? What is the equilibrium temperature of Kepler 69c? Next. Abdul is just running 2000 points ahead. What is the radius of Kepler 69c? 1.7 earth, 1.17 earth, 1.61, 1.16. This is one of the highest lead. 2382. This is like a clean sweep. Kepler 69c is a super Jupiter, super Venus, super Saturn mini.
Okay. There is a winner followed by Dash. Mahalakshmi.D.
Rush is 1095. Midhulashini. So well done, well done. So Adrit is the winner, followed by Dash. Then
Midhulashini and then
Midhulashini.
Mahalakshmi and then Rexy.
Okay, nice. Well done. Adrit. So the start is
Thank you, sir.
Adrit.
Thank you, Jaggu.
You can share the screen, the winners thing. Did you take screenshot of it?
No, I'm still in that page, Jaggu. It is
Oh.
still showing that winners.
It will still be there, Jaggu.
Okay.
I think end the thing.
I always love that near pots final finish. Amrita, Pranav, Kashikaa. Done?
Done, Jaggu.
Okay. So thank you so much, Naman. So let's give one huge round of applause for our Naman. All of you go unmute on the count of 3. 1, 2, 3. Yay. We have some few audience here sitting now. Okay, thank you, Naman. Okay, next. So I'm going to welcome 2 of the college presenters, Mahalakshmi and Midhulashini, and they are a first set of interdisciplinary bio-related research students of Vaayusastra Aerospace, and they are doing their first year MSc in food science, nutrition and dietetics. Future astronauts over there, please kindly get contact of these people, because these people may have solutions to feed you, because they are doing a lot of research in food industry. And they are from Sdnb Vaishnav College for Women, first year MSc. Okay, so Mahalakshmi, Midhulashini, you can start.
Okay, sir. Thank you for welcoming us. It's a great opportunity to
having been a part of research in Vaayusastra. So let's get started.
Yes, I can see the presentation.
Okay. Good afternoon, everybody. So I know you've all been watching a series of presentations on space foods. Not to bore you anymore, this is not regarding anything on space food, but preservation of space foods. So what is preservation? Why do we need to preserve food? As we all know, the astronauts stay in space for a longer period of time. Like as we preserve foods in our own home, they need to the foods in space also need to be preserved. So we'll see what are the techniques being followed in space. Food preservation is defined as the process of treating and handling food in such a way to stop or greatly slow down the onset of spoilage, and it can also prevent the foodborne diseases, and it also maintains the nutritional value, texture, and flavor. Sorry for the background noise. Okay, so coming to the types of food preservation in space, we have dehydration and rehydration, drying, irradiation, and thermal stabilization. Dehydration and rehydration. Dehydration is a process where the foods we take there cannot be they have lots of moisture content, so they cannot be preserved. So whatever food we need, you can see there as some examples like strawberries and these small tomatoes. They are we remove the moisture content in them, and then we store pack for them. Like some of the examples in Gemini mission includes grape and orange rings, cinnamon toasted bread cubes, fruit cocktails. All these are American foods. Turkey bites, applesauce. Okay, after the food is dehydrated, we'll come to rehydration. A dehydration process. It includes slicing, dicing, or liquefying prepared foods to reduce their preparation time. After the food had been cooked or processed, it is quickly frozen and then placed on drying plates and put into a vacuum chamber where air pressure is reduced. Heat is then applied through heating plates. Under these conditions of reduced pressure and increased temperature, the ice crystals in the frozen food boil off, and the vapor that is left is condensed back to ice on the cold plates in the vacuum chamber. Because what is the only thing that can be removed in the process of dry dehydration? After the food is being dehydrated, we need to dehydrate them. This process is so simple. After all the dehydration process is being done, we just put our food product in a, like you see the picture here. We'll seal them, and a small nozzle is kept on the top of our package, and water is then squeezed through a water gun. Back then it was water gun. We cannot measure the level of water we can insert. Like we need to given. So they have water dispensing machines. Now later we can adjust the measurements of water we need for each specific food items. So after water is being inserted or let in, the food is then and kept there for a few minutes, and we can mix them with our hands, and it can be straight away squeezed into a mouth, like the astronaut's mouth. Because of the size of the opening, food particle size was limited. Like in a small package, only half portion of food can be kept. Like after we have been eaten, the entire package has been emptied. The meal, the germicidal tablets, we'll just place them in so that the empty package will not inhibit microbial growth on any leftovers. So this is rehydration. You can see some examples of rehydrated foods here. This is the shrimp, which was before rehydrated and after rehydrated. And even chocolate puddings can also be dehydrated. And with the simple process of adding water to them, we can just, it is just turning back into the eatable form, edible form. Another step, another technique is freeze drying. This process was was found in South Africa. Like the people in South Africa, they have a mountain near to their country, like Andes Mountain, which is located in South Africa. The people there used to carry all the vegetables and fruits needed to be freeze dried. They go and keep all the fruits and vegetables needed to be freeze dried, and they leave them for, like few days or months. And when they go and take them again, the foods, like they are so fresh, they are frozen, like the water crystals are frozen there, and their nutritional values and texture or any other things is not changed. So this is how freeze drying process was found, like invented. This technique is also known as lyophilization, as you all know. To begin with the process, the temperature of the food is first lowered and a small amount of pressure is applied in order to force the water content in the food to freeze and form ice crystal. These crystals then undergo the process of sublimation. Sublimation is nothing but jumping straight into the vapor form from solid to liquid without getting into the liquid state. This process is repeated until the moisture content of the food is reduced by around 99%. That is only 1% of water should be present. There's also a second drying stage at higher heat. After the vacuum is broken and the material is sealed in the end of the process, the food is now freeze dried. So we can also have small spores in our food. These are due to the crystallization and sublimation in the air. You can see the ice cream sandwiches, which is the most important example. Yeah, this is what is the process. Like in first, the product is exposed to extremely low temperature until large ice crystals are formed. Then the freeze drying machine turns the ice crystals into vapor, that is without getting into liquid state. The food is dried to remove any moisture, leftover moisture, and they are packed into mylar bags, cans, or buckets together with oxygen absorbers to prevent or to help preserve them for further use. So these are the examples again. This is the freeze drying machine. So I have a few videos. Can I show them?
Yeah, please.
Okay. Can you all see my screen, like the video one?
No, you need to stop sharing, then you need to share this.
Okay, sure. You see how spinach is being dehydrated, like dehydrated ones which are rehydrated now.
Let's talk about space food. So today I've chosen dried spinach.
You can increase the volume.
Okay.
Prepare the spinach, you just attach it to the water distributor, choose the right quantity, and push the button. And it's like magic. Dried spinach, spinach ready to eat.
This is how we use the water dispenser in there, and this is a process of freeze drying.
I have seen this kind of idli trays in all local shops. I think all these are inspiration from space food only. This Maggie, instant hot water Maggie, then this cakes which are like this puffed up packed cakes. Stop at it. Mahalakshmi, you can side by side tell what's happening because we cannot hear any audio either.
Running.
Yeah. Mahalakshmi, can you try sharing it again? Like I think first 2 minutes.
In this machine, the pressure is the temperature is low and some pressure will be in the foods.
Something is happening, but I don't know what's happening.
My name is Ariel.
Okay. Yes, sir.
Okay, we can continue. Video is enough.
Okay, my part is over, and now Midhulashini will continue with her half. Midhulashini. Midhulashini, will you continue?
Midhulashini, we cannot hear you. Hello. Okay. Mahalakshmi, you can try calling me. I can't
Midhulashini,
hear.
okay, I don't know what's the problem. Okay, so I'll give her a call and be back.
Yeah, or you can continue with her content. If she's having problems with all.
I'll check with her.
Yeah.
So,
So boys and girls. Darsha, Pranav, Adrit, Amrita, what do you think about this preservation of space foods? Like there are points mentioned.
what, Jagu, will you repeat?
It's like what do you think about this preservation of space food? Is there any better ways, or what your points? What's your take on today's presentation?
Sir, why I said banana yesterday because these space foods are like dried and like hard. So if I eat banana, it would be banana chips. Like
Yeah,
banana chips,
Yeah.
pasta chips, strawberry.
Yes. But it will like freeze dried. No? So waiting for the presentations to continue. Little.
And one guy thought an ice cream sandwich, which was exactly looking real, and he thought it was real, and he ate it and he broke his teeth.
Yeah.
Yesterday I told Tata because it can easily put in the tray and take Jagu.
We wait for 2 more minutes, Vignesh. Then you can maybe try telling how to track James Webb Telescope. Or Vignesh, you can try sharing the simulation, like how to track James Webb
Jagu,
Telescope.
I'm currently eating my dinner.
Okay, finish it. Midhulashini is back. Disconnect. Ashok also. Midhulashini can say something.
Sir,
Yes.
could
You
you
are
hear me?
audible.
Okay,
Yes.
okay, sir.
Mahalakshmi can share your screen.
Okay, sir. Okay. Midhulashini, you can continue.
Yes. Good evening, everybody. I'm Midhulashini. I'm going to continue the presentation. Dehydration versus Maha. Back to the slide, Maha. Dehydration versus freeze drying. There are several differences between freeze drying and dehydration. In dehydrated foods, the foods may be withered and tough foods, whereas the freeze dried foods are crispy, crunchy, and it maintains the original shape. In dehydrating process, it removes the less water when compared to the freeze drying process, which causes the food to weigh more and have a shorter lifetime. Freeze drying removes 98 to 99% of the moisture content, while the dehydrating removes 90 to 95% of the moisture content, in which the dehydration process intends to break down the minerals, vitamins, and some nutrients which are present in the food and making the nutritional content which are slightly lower than the freeze dried foods. Next slide. The first picture is the freeze dried plum, in which the plum became crispy and crunchy. The second picture is the dehydrated plum, in which the plum became tough. On below the plum, there is an electric plate in which they dehydrate the foods. The third picture is the freeze dried strawberries. The foods become crispy and crunchy. The fourth picture is the dehydration machine, in which they have used to make the foods to dehydrate. Next slide. Next one is irradiation. It means the exposure of radiation such as X-rays or gamma rays. Food irradiation is a technology that improves the safety of the food and extends the shelf life of the foods by reducing or eliminating the microorganisms and insects which are present in the food. It does not make the foods radioactive, and it compromises the nutritional quality in the food, and it is changes slightly the tastes, textures, or appearance of the food. The irradiated foods such as beef steak and smoked turkey. Then in NASA, astronauts can eat the meat that can be sterilized by irradiation to avoid getting some foodborne illnesses such as allergies, etc. When they fly in the space. We can see the irradiated food is smoked turkey and steaks in that slide. Next slide. Mahalakshmi, next slide.
So Adrit has some doubt. Yes, Adrit, if you have any doubts, then ask.
Slide. I have a doubt.
Yes, yes. Sir.
In irradiation, we are exposing the gamma rays, sir, but isn't it harmful for the food?
Mahalakshmi, Midhulashini, there's a question. So in space, the foods are high possibility the foods may get exposed to gamma radiations. How harmful it is?
It may affect the nutritional quality of the food.
Okay, by end of presentation, you can answer all the questions. I'll ask them to put the questions in the chat box. Continue.
Next slide. Next one is Thermo Stabilization. As the name Thermo means heat. This process is defined as the preservation of heat, usually take place under pressure. In this process, this heat is destroy all the microorganisms such as viruses, bacteria, which are present in the food, and it also alters the catalytic activity of the enzymes. Then the thermalized foods or heat processed foods, it can be stored at room temperature. Example of thermostabilized foods are fruits and fishes, which are thermostabilized in cans, and it can be easily opened full tap cans, which are similar to the fruit can that can be available in the grocery stores. Then puddings which are packed in the plastic cups. And we can see the slide. There are different kinds of meat which can be thermostabilized and eat. Next slide. Thank you,
Yes,
sir.
we are over with our presentation and you can proceed with the questions you have.
Is there quiz?
Is there any quiz? So that's
No, no, sir.
No, sir.
Okay, so you have few doubts from our audience. So they're asking about like இப்போ ஏதாவது food அந்த radiationக்கு expose ஆனா what will happen to the food?
Like சார் இப்போ நம்ம ஃபுட் irradiate பண்றோம்னா அந்த அளவுக்கு they are not harmful at all. Like that does not make the food radioactive. That's it. It just kills the bacteria or the pathogens living in that food. So it is not harmful.
Okay. It's not harmful. So maybe
To a certain extent.
I want to know more about the irradiation, how the process happens. Maybe that we can have a second.
Raghu, shall I show the James Webb?
Wait, after Kashika. So, yes, Kashika. So, thank you, Mahalakshmi and Midhulashini. So, this is their first live presentation. Let's give a huge round of applause for
Awesome.
Midhulashini and Mahalakshmi. Yay.
Awesome presentation.
Thank you, guys.
Okay, next we have our presenter from grade 9 Kendriya Vidyalaya Ashok Nagar. So she is going to present on this famous very trending or very new topic which was trending yesterday because it was launched only launched into space. It was live as well yesterday. Let Kashika explain more about the topic. I'm not revealing the topic. You yourself can reveal.
Sure, sir. So again, before I start off the presentation, I'll just ask one quick question. Who saw the launch yesterday?
Who is this?
Who saw the launch yesterday of the James
Who
Webb
saw the
Space
launch yesterday?
Me.
Okay, Vignesh.
I saw it in news, Kashika.
Okay, Adrit.
Right. Again, one small question. Did you notice which rocket it was lifting off from?
Which rocket?
I knew the rocket is
Ariane 5.
Ariane 5.
Right, Ariane 5, that's it. Perfectly right. And do you guys have any thoughts and ideas on why it was Ariane 5? Maybe they could have used Falcon 9 as well, but you know why specifically Ariane 5?
Because that rocket is little bit mass. I think so.
It's mass, it's a little big. Very close to the answer. It's
Kashika on voice breaks.
Yeah.
Hello.
Jagu, but they just show the live, but originally they launched on 26th December only, 22nd December. But yesterday they put the live in YouTube.
Okay. No idea.
And Jagu, I asked us how to track this James Webb telescope.
Yes. So that's what
Due
after
to all of
presentation,
our facilities, Jagu.
Kashika
I just got it on December 23rd because they asked for paid money as well. But we have websites now. I just told that we are a company and I just put our website link and they allowed us to track the James Webb telescope. But mostly tomorrow only they would have given to everyone usage because I access on 22nd. That means that some people would access only by yesterday only, I think so.
Okay. So we wait for Kashika for 1 or 2 minutes. Else, Vignesh, you can go ahead and explain. Okay,
Okay.
Kashika is back. Kashika is
So Jagu, about this website,
wait. Let her. She just joined, then she got disconnected. I'll tell you.
Jagu, shall I start now?
Wait.
So, sir, can you hear me now?
Yes.
Right. I left the meeting. I don't know why. But let's continue the discussion.
Yeah.
Yeah. So before I know I have a presentation. I'll show it to you. But I have few questions before that, right? So I know that a lot of you have watched the James Webb Space Telescope launch yesterday, and some of you might have watched it, live or in the news or later on. And you also told me that it was launched on Ariane 5, which has a specific reason. Some of you told me it was because of the mass of the rocket, or it was because of the size of the rocket. I will definitely go with the size, precisely because Falcon 9 does have the payload capacity of lifting the James Webb Space Telescope into space. But the specific reason why Ariane 5 was chosen, because see, even inside the rocket, the James Webb Space Telescope was folded because they couldn't fit that huge mirrors into the rocket itself. No rocket is there, no rocket exists in this world that could actually, take up the size of James Webb Space Telescope, that huge mirrors. So what exactly the technology that underwent in this process is that the mirrors were actually folded and then they were kept in the rocket. And then when it goes to space, it will, come back, it will unfold itself. I just want you to imagine the complexity of this entire mission itself. How complex it can be, the engineering, the process of it. It definitely is a complicated engineering and science involved in here. So it's definitely I'm trying to join through my laptop, so that's why I'm trying to speak through about the topic as I join through my laptop. So and I want to know what you all know about the James Webb Space Telescope.
I knew that it's bigger than our Hubble Space Telescope, and it can take more data. Like it can go in search of exoplanets,
of modern.
Right. You absolutely, you're all right. And
That is the most advanced space telescope of this century.
and it's also bigger than Hubble telescope, and it can collect more data as well.
Exactly, you're absolutely.
And it can give it signal waves for more distance.
It is going around the sun.
Absolutely.
And it's going like around. It's going like around 250, 25, 250,000 kilometers, and also 160 miles, and also it's also going on 832,000 kilometers. Okay, from 250,000 kilometers to 832,000 kilometers. 832,000 kilometers.
Say that's no precise data. Definitely. So I hope you can see my screen, or is it blank?
It's loading.
Yeah,
it's loading.
I know where to begin and know where to go with the presentation, because I see that a lot of you do have.
Your voice is breaking, Kashika.
More facts, more physics involved, more engineering, more science involved in this amazing project. I think I'm sure that everyone is excited to know about this. And is it still blank or is it still loading for you all?
I think you need to reshare.
I'm going to stop sharing. Right. Let's go again. Okay, can you all see the presentation now?
Loading.
Still?
Kashikaa has started screen share. You can see that black screen. We can see now.
Okay, we can see. So as you said, everything is, about this space telescope is new, and a lot of new technologies were involved while, creating this entire new project. Actually, to be honest, this project, it actually started in 1996. So remember, it actually, the ideation process actually started in 1996, but later on, the actual development, the actual process, started around 2002. So that means we are almost going to enter 2022, right? So do the math. Tell me how much, how long did it take to develop this entire project? Consider it from 2002. Can anyone do the math?
10 years. 10 to 9 years.
10 to 9 years. You sure?
Yes, I'm sure.
Sure. Okay, the project started in 2002. So now we are going to enter 2022. Sure. So 2002, that means 2012 passed by, and we are almost going to 2022. That means 2 decades. 2 decades means 10 time, 10 years and another 10 years. Definitely, a lot of work involved in this. So, right. And so again, so I think you can see the first image. So first image you can see is the Horse Nebula. The Horse Nebula, which is, you can see is, the first image that is actually produced by the Hubble Space Telescope, and the next image that you can see is a little bit darker. It's from the infrared spectrum of light. Alright, because the James Webb Space Telescope is specifically designed to go for this particular spectrum of light, because Hubble could only see visible spectrum and ultraviolet, and that means that a lot of dust and dust particles or any gas molecules that is actually hidden inside the visible spectrum of light. When it comes to infrared spectrum of light, we'll be able to see all those tiny particles. See, if you could observe the image, you just see the difference. How many stars can you see here, and how many, let it be stars, maybe any other, it could be planets or something, but I am sure it's stars. When you come to this part of the image, it's definitely a lot of stars. You can see a lot more in this Horse Nebula rather than you can see here. And this is the famous, yeah. All right, let me come back to this. So definitely you can see the difference, how much, so the process that Hubble takes and the process that happens, the difference in the image itself, you can see, you can get a lot more data through infrared spectrum of light. And that's one of the specific reason why James Webb was launched. Let's go to the next slide. So how did it all begin? As I said, the idea, the concept started around in 1996, and now we are approaching to 2002. But the actual development, the actual physical construction of the entire project started around 2002. That means it's a work of 2 decades. But if we consider the ideation process as well, it's around 3 decades. Just imagine putting your heart and your hard work into a project, into something for 20 long years, and it's finally up in space. Just feel how all these scientists, all the people that were involved in making this project would feel after a successful launch. And definitely I think one of us will go and work on in these amazing projects as well, and definitely you'll feel the excitement feeling. And did you know, actually it wasn't actually called James Webb Space Telescope, it was actually called NGST, which standard for Next Generation Space Telescope. So after Hubble was launched, James Webb is most commonly known as the successor of Hubble, which basically is the after grandchild of Hubble, as you can say. So, but it was actually called Next Generation Space Telescope. But after they changed it to James Webb Telescope. It's because of the second administrator of NASA. So he ran NASA. He was the administration. He was in the administration council from 1961 to 68. You might see, why did they name an entire important mission as James Webb Space Telescope after his name, right? It was because in the 1960s, do you remember what war was going on? Anyone?
Yes, I know. It is the war, Indo-China war.
Can't hear you. So I think you are about to say something, but I cannot hear you anymore. So it's actually Cold War. So Cold War between Russia and China, the space race was going on. So in this year, the 60s, 1960s was the time where NASA was at its peak, right? The Apollo missions were going up. People are going to the moon. People are going to the space. Space missions. A lot of space missions were happening, putting human on a space vehicle and sending them up into space. A lot of that kind of things were happening, and he was the administration. He was the NASA administrator during those consecutive years, right? Right. So he was in the formative years of NASA. The very important stages where NASA underwent a lot of competitions. But what this man believed is that space was more than a competition and politics. It was about passion. It was about the passion of going into space, the passion of exploring more. Do you all agree? Do you all agree that is space all about politics and who's going there first, who's not going there first? Is it about that? No. You can just show your head nod. I can see your cameras. Right. So it's definitely not all about politics, who's going there first, who's going there last. And I hope you all agree with me. It's about the passion. It's about discovering something new, discovering the unknown, and unraveling the secrets of the universe. So let's know. Actually, his name is James Edison Webb. So that's where James E. Webb, Edison from E, came from. So let's go to the next slide. We'll know more about James Webb. So he was as I said, he was NASA administrator. That's old information. Let's get on to some new. So did you all know that he was? All right. So, yeah. He was not a scientist he was not a scientist. He was not an engineer. He was nothing related to science, right? Did you all know that? So see, someone who has nothing to do with science, but still managed to become the administrator of NASA, one of the major leading space agency, which is absolutely involved science. He was a business person. He was an attorney. Attorneys basically involved with law and stuff. But that's kind of the passion of workforce that was needed for an administrating job. So he was there in a period where John F. Kennedy was the president, and he believed that James E. Webb would be a perfect role for this particular job. So, and then he became the NASA administrator. He was the second NASA administrator, actually. So, the James Webb Space Telescope was not only by NASA. I know whenever a mission happens through NASA as well, a lot of people do believe that it was only by NASA. So they all focus, they all put the social media content about NASA. It's just not about NASA. NASA is a great space agency, but there are more work of other space agency universities. So to be honest, 300 universities, private space sectors were involved while doing this particular project for particular James Webb project for 2 decades. So we had NASA, we have ESA, we have Canadian Space Agency or Northrop Grumman. If you don't know what Northrop Grumman is, I would suggest that you go and look up at their website or their company itself. It's a private space sector, definitely. And there's also one more thing. There's a space telescope institute. So after Webb is launched, it won't be under the control of NASA, ESA, or Canadian Space Agency. It will be in the control of these two. So these two companies. So that's why partly they will be operating James Webb, not NASA or ESA or Canadian Space Agency. So as I said, it's a $10 billion gamble. It's $10 billion. That's huge amount of money. Even when even people they have $1 billion in their hand, they say they are a billionaire. But this amount, $10 billion, is just involved in this James Webb telescope. And why I say it's a gamble? Because when it goes up to space and it fails, the entire mission fails, $10 billion lost. Nothing, we can do nothing to retain that money, right? Huge amount of money. So it is the most powerful and the largest space telescope by NASA or any, to be in fact, it was in space, actually. In space, as the largest space telescope and the most powerful, and it's going to see in the infrared spectrum of light. Let's see. And have you all heard of the 7 minutes of terror? The 7 minutes of terror by missions were landing on Mars. If you do, you can just raise your hand. I'll be sleeping.
7 minutes.
Right. Yeah, I was hoping 7 minutes of terror. It's basically where they lose the contact with the rovers or any spacecraft that's landing on Mars in that 7 minutes when it reaches the atmosphere until it reaches the ground. Or they will lose the contact with the spacecraft itself. So they will know nothing until for that particular 7 minutes that the spacecraft is successfully landed on the ground or not, or something malfunctioned on the way. They would not know actually. So it's just like, but it's slightly different here. 30 days of terror is where James Webb is reaching its home. So James Webb is not still in its right orbit. It still has to travel for about 1 month. That's particularly 30 days here. So it will go to a point called Lagrange point 2. As you can see here, it's L2. It's about 1.5 kilometer further away from Earth. So definitely it's a long distance travel, and it's a 30 days of terror. But people still have contact with the space telescope. But still, in those 30 days, if something happens, something malfunctions, and after reaching Lagrange point 2, it will unfold, right? It will unfold. If something malfunctions right down there, nothing could be saved. Astronauts have to travel 1.5 kilometers away to just fix it, right? Hubble was much closer to Earth. So, when something was malfunctioned, something went wrong with Hubble, astronauts could easily go in a space shuttle and save Hubble, But James Webb is much farther away. I don't know if that is possible in that case, but we won't let that $10 billion go into waste. If something goes wrong with Webb, particularly there will be missions to save it up. But let's hope for something positive. I hope for something positive here. So now let's speak about Hubble's home. Webb's home, James Webb's home. And you all have a home. You all stay in a home, and definitely James Webb will stay in a home. It's called the Lagrange point 2. And have you ever heard of Lagrange points? Anyone? I see Vignesh nodding his head. Have you heard of Lagrange points, Vignesh?
They will learn in the later grades.
See, Adrit is speaking, but the only fact is that I cannot hear him. Is like, can you hear me? Can you hear Adrit?
Hear you.
You can hear me, but I cannot hear you properly. But that's fine. But I think if you know about the Lagrange points are basically gravitationally stable points. Don't get too much confused with the word gravitationally stable points. So here you can see what is this? This is the sun. What is this? This is the Earth. And they both have gravitational force, right? Every object in the universe has its gravitational field. It will exert a force on one another. That's called the gravitational force. So according to Newton's universal law of gravitation, there are few certain points where in space, where between Earth and the sun, where the gravitational point is very stable. and there are 5 Lagrange points: L1, L2, L3, L4, L5, right? So particularly, but Webb will be traveling to L2. So you have any idea why L2? Why Lagrange point 2? I have said that it's a, it is definitely a gravitationally stable point, but any guesses why L2? Why specifically L2? And one clue is that James Webb will be seeing the universe in infrared light. Any guesses now? Right.
Yeah, explain. You can find exoplanets.
One exoplanet. We definitely, that is one of the key aspect, one of the key rule of James Webb's launch itself. To find exoplanets. But there's also one tiny reason actually, and it's actually the answer is right there on the picture. If you want, just look at the picture and you might find some answer. I hope I haven't given some tricky questions easy. So the fact is that, as you can see, James Webb is opposite to the sun, right? It's not directly facing the sun. The Earth is in front of, it's behind the Earth. That means it won't get a lot of solar radiation, as you might say. But you might ask me a question, then how it's going to get its solar energy? Definitely, it will get enough solar energy for it to run. But the fact is that when the sunlight actually reaches the infrared part of the spectrum, the telescope has to be cold because its electronic subsystem has to be cold, or else what would happen is that this solar radiation, this solar rays would actually disturb the images that is given to us by Webb. That means that the images, the sunlight would definitely cause a distortion in the images, that because it's specifically in the infrared part of light. So if we put James Webb in any other point other than L2, what would happen is that we'll get some blurry images, right? So the safe place for it to stay is away from the sun, enough away so that it would still get its solar power, but still be cold. So I think it has to be in around minus 273 or 93 Kelvin. This is Kelvin, all right? Kelvin. Kelvin away from in that particular temperature, in that cool temperature. Remember, it's negative, right? It's negative. It has to stay that cool. Or else, the second reason is also that this solar radiation, it can emit the infrared light. It can emit the infrared light that's coming away, and it will cause a distorted image in James Webb. Right. So, and so what is the key focus area of James Webb? So the key no, the missions would jump. So the fact is that the L2 is specifically a point where a lot of space telescopes are placed because it's in a perfect gravitationally stable position, and but so are all the other Lagrange points. Also, the fact is that it's a little away from the sun. The instruments have to stay cool because it cannot get heated. So it's not that cold. It's not that cold so that the images, the instruments inside the James Webb, the missions inside the James Webb would freeze and won't jam. But it's in the exact perfect temperature where it can also run, but it can also take the images. Remember, the one key factor is that James Webb is taking images in infrared light. If we get too much solar rays, what will happen is that it will disturb the infrared spectrum of light, and all we get from James Webb is the distorted images, distorted, blurry images, and we won't want that, right? We won't want that. We need beautiful, clear images of space. No, it won't. The cold won't jam any instruments, and the missions won't jam. It's in the perfect, ideal condition. Right. What is the key focus area of James Webb Space Telescope? And JWST is the short form of James Webb Space Telescope. All right. And actually, there was a really good question from Adrit. And I thought, because that's an important factor. That's a real cost, right? That's an important question. Thank you, Adrit, for asking that. So one of the key factors where JWST will be focusing on the first light, which came in, that first light from the universe. You know that telescopes are, time travelers because they see something that happened in the past, right? Because light reaches at a specific speed at a specific time. So James Webb will be focusing on seeing the first light of the universe, first particular light that came out in the universe. So particularly the universe, began with all the elementary particles, like protons, neutrons, electrons, and stuff, and then they merge together, and then they form light. Light, particularly light. So James Webb will be focusing on getting the first light of the universe. That's absolutely insane for me. Something that cool. And the second part will be seeing how the formation of galaxies started, how galaxy formed, and something at that gigantic scale. It would be, it will reveal a lot about the universe itself. And the next step for James Webb, if we focus on this slide, the next step for James Webb will be seeing is that how stars evolved, how stars formed, how the first stars and planets formed. Protoplanetary planets is that, the planets that formed around the protoplanetary disk. If you don't know what protoplanetary disk is, it's nothing but when a star is formed, not completely. You can see a tiny blob right here, right? A tiny light blob, and then there's a full gas circling around it. This is called the protoplanetary disk. So from that protoplanetary disk, we have planets forming around us. These are called protoplanetary planets. So James Webb will be seeing how to get the light of first stars and first protoplanetary planets formed. And definitely it will be seeking for exoplanets. And we had an amazing presentation about exoplanets itself. All right, so let's see. So Hubble versus James is definitely a perfect comparison. Definitely their figure is different, and Hubble has this beautiful golden mirrors. And why golden means it's highly reflective, and it has an elemental properties of, gold is perfect. It's highly unreactive, and also it's that gold has an high reflection rate. So that means it will be definitely useful for infrared spectrum of light. So, and that's major two differences between Hubble and James Webb is that its structure. It's definitely very different in structure, and the second thing is that the way it sees the universe, it's definitely different. The way Hubble sees the universe in visible light, and it also sees uh, the universe in ultraviolet. But James Webb is specifically designed to see the universe in infrared spectrum of light. And that actually brings us to the end of the presentation. But this is just a part one of James Webb. I'm actually in the next presentation video, I'm trying to do a part two where we go very deep into the science of James Webb itself. So this is just part one of it, and the next part we'll see more science and key details in James Webb telescope. So, and again, no quiz today. I want to finish the entire segment, like the entire James Webb's JWST segment, and then I'll give a massive quiz for everyone to attend, just to see if you remember what we studied or what we learned in the last week, as well as in the next week. Definitely, there will be a presentation on James Webb part 2, where we'll dive more into the science itself. So I hope you learned the surface, the underlying surface of what James Webb was, and I hope that in the next part we'll all be joining and learning again about James Webb in depth and more about it. Thank you.
Yakush, I have a website. Shall I share it?
Okay, Vignesh has something to share about James Webb.
So basically, this is the James Webb telescope where you can control the spacecraft. You can see how you can drag the spacecraft and do anything which you wish. So first, let's see about this tracker. But usually you can do it today. But I accessed it on 23rd due to all of my facilities with 3 websites. But you can do by today. You can do. So here they have been put on the distance. So the distance is 17.5062%. So its miles are increasing from Earth. So about these you can learn new things. case for deployments. And this is MCCA. It helps us to send a signal back to Earth. It's a transponder. And also, we could also see about further details like some videos also you could see in YouTube. You would go to the channel itself. So you could see many things on this website, and also you could see countdown. I think so. This might be a game. Okay, it's giving me to the same page. You can track it, and you could also see here whatever you want. And also, I have a comparison about this. The James Webb Telescope and Hubble Telescope. So here you could get more details about these.
Okay. Nice. So thank you, Kashika. Thank you, Vignesh. So today is like the Christmas weekend or the New Year weekend started. So
About next week is their class.
yeah, definitely. There's a New Year presentation, Future Scientist Meet. We won't miss it. At least we can have at least 1 or 2 things. Okay. So thank you, Kashika. So let's do an huge applause for Kashika. You can go unmute Adrit, Vignesh, Midhulashini. Thank you. Okay. See you all next week with new set of topics, new set of presentations.